To talk about BIM, I would say it's time to call Antonio Cianciulli on stage, Marketing Director of ACCA Software, because it is one of the world's leading producers of software and services for the architecture, engineering, and construction sectors. It is a pleasure to have you at the ESRI conference. I know you have many things to tell us. I leave the stage to you.
All right, thank you, and good morning to everyone. For us, let's say, the task is a bit more burdensome, because we have to say what is behind all the beautiful things we talked about this morning. In fact, we will talk about the main technologies at the base of the construction of geospatial digital twins, namely the integration of BIM and GIS. This will allow a smart management of our construction future. And I'll start. You are much more experts in geographic information system than me, so I won't talk about it. Instead, I'll say what concerns us more, that is, what is the building information modelling? I'll do it quickly, obviously. For centuries and centuries, we have drawn structures and projects and have also built beautiful things, as we can see here in Rome, undeniably, right? And we did this through drawings that represent, for those working in the construction sector, plans, sections, elevations, a communication language, obviously. BIM completely changes this paradigm, because with BIM one starts to build models that, for example, in a building, I made a simple one, are made up of objects such as walls, doors, windows, pillars, stairs. But these objects, be careful, are not just geometric objects. Earlier I heard about three-dimensional objects and so on. They are not just objects that tell us the height, width and thickness, but they are also objects that have informational parameters inside them. So, for example, for a window, we know the mechanical resistance, the fire resistance, the thermal conductivity, and so on. That is a huge series of information. In fact, BIM exactly means Building Information Model. That is, it changes from drawing to an informational system of the construction. And the good news is that this information is not scattered randomly, because otherwise it would be a real problem, especially for the GIS, and because there is a language that is an international standard called IFC Open BIM, which has created a classification of this information to meet all the informational needs we have for any type of construction. For example, using the building example, for a window, there is a class in the IFC Open BIM called IFC Windows, where all the parameters we talked about earlier, that is, all the data, are organized in such a way that any software can read them, write them, enabling dialogue worldwide in the same way, and especially it can be done by everyone involved in the construction sector on a platform called the Common Data Environment in Italy, based on international technical standards, and thus this informational model is continuously enriched, never ceasing to gather data. Within it, therefore, from the design phase, during execution, during the operational phase, so inspection systems, monitoring, maintenance until the end of the life of this construction that we are representing. Therefore, an information model made on a common data environment. Now, what you have seen so far, all the beautiful things we have seen so far, we managed to achieve them because all the information about constructions in the world, infrastructures, buildings, roads, railways, and so on, can interact dynamically with the GIS. So we have the possibility to have all this information thanks to the dynamic integration between the common data environment and GIS model data with ArcGIS directly on the GIS. Our platform, which is called BIM GIoTwin and connects the common data environment with ArcGIS, has two main features. It does this with large files. We can share the entire built world, everything. We have no limits, and we do it on the IFC OpenBIM. This, for example, is just one building. To give you an idea, it's a hospital, as you can see, and it has 164 federated models in IFC, and there are 3.2 million objects. This is the fluidity with which we manage, and of course we can simultaneously see the architectural models, the systems. If we go on each object, we are on the GIS, we see all those parameters and that information of this conduct. So you understand, or if we go to the phone, we see all the information of the phone. If we go to the cabinet, we see all the no little table. We see all the information, so 3 million and 2 objects for, let's say, 100 pieces of information are hundreds of millions of pieces of information for a single building. Imagine what happens for all the hospitals in Italy, or all the hospitals in the world, all the infrastructures in the world. We will have an extraordinary amount of information on GIS. You might ask, how is this done? For us and for Esri, it is very simple because our usBIM GeoTwin behaves like a widget that is inserted within ArcGIS. Then that's it. Look, I just choose the map on which I want to share the data, the link where I have inserted the models I want to share, in the common data environment, which are also georeferenced, and I find them there on the map. Building a new BIM layer, or rather an application within ArcGIS. So with that application, I can share other tools, for example, like zoom, measurements, all the information that application, creating a new application to read BIM data. And I can turn a layer on and off, like any other data layer within the platform, and customize the functions according to the customer's needs. When I have the information from the models note, I have data information as well as 3D. I can easily make geospatial queries and, for example, identify in this case all the boilers and window frames with all the data, but also on a 3-dimensional level. And at this point I do not have a BIM model, I have thousands of BIM models to query. All this information can obviously be combined with other widgets, with other data from the GIS world. So if I have to, as in the case of the municipality of Rome, previously conduct studies that combine population with new interventions in the city, I could share a layer on a new redevelopment project, for instance with the population bars indicating the population density of all the surrounding areas. La densità popolativa di tutti quanti gli altri zone limitrofe. Or a very visual example, I could share, for instance, the weather conditions, and this look seems trivial. But for construction sites, it's very important because the work journal is obviously influenced by this. The important thing we need to understand is that we have shared the common data environment with the GIS. So those IFC data that we have inserted within the GIS are not dead data. They are not static data. Because if engineers, architects, surveyors and companies continue to work on the models and can also do so collaboratively, the model dynamically, because we are practically always on ArcGIS, they update, so whoever makes the queries always finds this data updated. It would be a problem to have outdated data, and making queries would be useless. We conclude with some case studies here on a single map. We have placed 9 million objects related to different models and 32 billion points of point clouds. Is it an airport? And you see the detail of the MEP systems. We can share any type of infrastructure, linear infrastructures like railways and roads, bridges. We can do this practically with data federation, so point clouds and models together. For each object we have the information. Remember, for each object. Start to think about how many billions of data points we have transmitted to the GIS and what can happen. Archaeological sites couldn't be missing here in Rome. In Italy, we have many monuments and historic buildings. And I will show you something that is being presented today for the first time worldwide in Ferrara, which is our intervention using BIM procedures for the restoration of the Chair of St. Peter and Bernini's canopy. So all these process-related information, including BIM, are integrated into the GIS. There are telecommunications, infrastructures, power plants. Eterna is one of our clients. So imagine the built world, all the data of the built world on the GIS. How many utilities does it have? I'll show you two last cases. One practically realised by Camia, Dixi, Reluis, and the CSA Consortium, which aim to integrate GIS, BIM and practically the Internet of Things to monitor the bridges in the Campania region here, or we calculate in real-time stresses and displacements to calculate the risk of the infrastructures in real time. We can see them directly on each of the bridges, for example in this case of the Amalfi coast. The other project we just saw, Rome Digital Twin, has combined GIS information, so population, what we mentioned earlier, territorial information, with the 100 new redevelopment interventions that will change the face of our city. This is a project, as was said, that was presented at the MIPIM in Cannes, with great success and interest. I conclude with thousands of BIM models of a city, because this technology, as we mentioned earlier, is the basis of the territorial digital twin, the basis of our smart cities, and the basis for providing new services, a better life for all of us. I thank you for your attention, and I'm available for any clarifications.